Hello students, in this video I'm going to answer the previous year's questions of AHSEC final examination of the chapter Magnetism and Matter of Physics class 12, okay, under Assam Higher Secondary Education Council. And I already have made many videos on different chapters of physics class 12, chapter 1, 2, 3, 4, okay. And also I have made videos on optics as well, okay, so please do watch those videos. So if you can't find the videos, then just type PYQ, then type the name of the chapter, and also type maths tutor likhoje, that means my channel name, okay, maths tutor likhoje. Then you will get that particular video on which chapter you want, okay. So just type the chapter name and just do one thing. Let me tell you. First, what you need to write, you need to write the PYQs, or simply PYQ, then chapter name, then write the channel name, my YouTube channel name, okay. Then you will get that video. You can also follow me on Insta. This is my Insta ID, OJHALAKHYAJIT123. that's my Insta ID. You can follow me on Insta. So now let's start. So here is the first question. A 2 ampere current is flowing through a solenoid having 1000 turns per meter, okay. So number of turns per meter, that is N by L, that is given 1000, okay, 1000. So which is also represented by small n, right? Calculate the magnetic intensity H, okay. We need to calculate the magnetic intensity, right? So how to calculate that? Current is given, that is 2 ampere, okay. So hope you know this relation. First let me write this given data here, okay, to solve this problem, okay. So let me solve this problem here. So hope you know this relation. B is equal to mu naught Ni. Hope you know this, okay. And B by mu naught Ni, this is nothing but magnetic intensity H, okay. So how to find that now? Small n is given, that is 1000 into I is also given, that is 2 ampere, okay. So if we multiply, then we're gonna have 2000, right, ampere per meter, okay, right. And let me answer this question. What is the unit of magnetic flux, whether it is a vector or scalar quantity, right? And unit of magnetic flux, we know that magnetic flux is given by B dot A means the area vector, right? So you can say the SI unit of magnetic flux is Tesla meter square, or you can say Weber, okay, Weber, okay. So 1 Weber is equal to 1 Tesla meter square, right? So this is the SI unit of magnetic flux. As we have here dot product B dot A, so that's why this must be scalar, okay. We know that vector dot product of two vectors is scalar, okay. Hope you know this thing. So let me write the answer here completely. Let me write the answer to this question, okay. So SI unit of magnetic flux is Weber or Tesla meter square, and it is a scalar quantity, scalar quantity, right? So that's the answer. Now let me take the next question. So you know that magnetic potential energy UN, this is UN, sorry, UM not N, is given by minus M magnetic moment dot B vector magnetic field. Okay, so let me write it properly. UM is equal to minus M dot B, right? So where M is the magnetic moment, state the conditions for obtaining most stable position and most unstable position of magnetic needle, right? Suppose we have a magnetic needle here. Okay, this is a magnetic needle. Let me draw it properly. In a magnetic field, north pole, south pole, in a magnetic field. Okay, so what will be its most stable and unstable position of this needle? That has to be written here. Okay, so let me write the answers. So now you see answer to the first one. So now first let me write this. UN is equal to M dot B. Okay, so now here you can see that it can be written this way, minus MB cos theta. Okay, now you see, so the direction of magnetic moment should be south to north. Actually, this is the direction of magnetic moment vector, right? So south to north. So we used to measure the angle with this direction, south to north. Okay, now you see, when this is the magnetic field and this is the magnetic needle, when they are parallel, south to north is in this direction. This is the magnetic vector, magnetic moment vector in this direction, south to north. So if these two are parallel, this magnetic field vector and this magnetic moment vector, then theta will be 0. Then theta will be 0, and cos 0 is equal to 1. Cos 0 is equal to 1. In that case, this potential energy will be MB, right? Okay, now here you see, and this is the minimum value of potential energy. So that's why the most stable position, therefore the answer, the most stable position of a magnetic needle in a uniform magnetic field is where the angle between M and B vector is 0, right? Is 0. So now when it will be unstable, okay, so when this magnetic moment vector will be in opposite direction to this magnetic field vector, that means the angle between these two is 180. Theta is 180. In that case, potential energy will be minus M dot B, that gonna be equal to minus M B cos 180. Cos 180 is minus 1, so that's gonna be UM will be M into B, right? That is maximum potential energy. Okay, so So in that case the magnetic needle will be unstable. Okay, so let me write all these things here. Just give me. So now you see the answer to the second question. The most unstable position is, where angle between this magnetic moment vector M and magnetic field vector B is 180 degree. Okay, that is the most unstable position. So hope you have understood this. Now let me take the next question. So if current flowing through a coil of n number of turns, how many turns? Number of turns is n and area of cross section is A. So there is a coil, how many turns are there? N number of turns, and this area is A. This area is A, and I current is flowing through this coil. Okay, so what will be the magnetic moment? Magnetic moment capital M, if there is only one coil, then that is given by I into A. If there are n number of coils, then we have to multiply it with capital N. So this is the required answer. Okay, so hope you have understood this. So don't write this expression only in examination, just write number of coils. First write number of coils, number of turns in the coil, number of turns in the coil, number of turns in the coil, and current in the coil I, area of cross section is A. Therefore magnetic moment is this, right? So hope you have understood this. Now let me take the next question. So if two materials A and B, it is found that susceptibility is greater than 1, very greater than 1, and for the material A, and for the material B it lies between the -1 to 0. Okay, so name the type of the materials. Now you see material A, metal A, for metal A the susceptibility is very greater than 1, so it must be ferromagnetic. So it is ferromagnetic. Right, and you see, and for metal B the susceptibility is given that it is in between -1 and 0, so it is diamagnetic. Okay, so this is the answer, right? So that's all. So hope you have understood this. So thank you for watching. See you in the next video. Bye bye.